Welcome, guys. Welcome to another episode of the Cryptoverse DAO. This is your host, Dharma Sutra. We're at lesson 2 on Solidity. I am a little bit sick today, so I do apologize for the vocal, the quality of the vocals not being up to scratch. Um, Last time we looked at a brief intro, a basic intro into Solidity. Today we're going to look at effectively the next step. Once you know what Solidity is, you're going to want to install the compiler and start coding, basically. Start writing up your smart contracts. Go build your decentralized apps. Um, so what is compiler installation, right? What is a compiler? That's something we're going to be looking at today. We're going to be looking at kind of the basics. I mean, I could give you an overview. I could just tell you what a compiler does. But to truly understand the way that it works, we have to go over a number of nothing too crazy in terms of like how complicated the content is, but just some basics of program execution, some basics of coding. So if you're like an old school coder, you might hear some stuff repeated. This might be stuff that you know already, basically, but then again, I mean, I'm a brand new coder. It's all about like relearning or something. I don't know. I'm trying to think of something that's like philosophical and nice to kind of segue into this lesson, but I'm drawing a blank. So let's just get right into it. Um, why use a compiler at all? Well, the answer is kind of simple, but there's layers to it. So, when you think about coding, what is it that you're doing? You're typing in instructions, right, in code, which a computer is then going to read and execute. Basically, if you think of it super simplistically, that is what you're doing with coding. Now, the thing that you're typing in is what's called source code, right? The sort of malleable, tangible code that you as a human being interact with. Now, source code gets transformed into object code, and it gets transformed from there into executable code. Basically, the things that you're writing down, they need to be kind of processed such that a computer can act upon those instructions. And a compiler is what does that, basically. It transforms instructions from format A, which is source code, into format B, which is object code, right? It compiles it into object code, and the further arrangement of that object code is what constitutes like an executable program. So the jokes about um, Minecraft.exe, whatever.exe has stopped working. That .exe is kind of like the end point of that three-tiered process of coding, of turning source code of a human being sitting at a MacBook typing away into the final stage of the process, which is a user interface that it's a program. It's a program that has a user interface, among many other things, because there's a lot that goes into um, kind of an executable program, if that makes sense. So basically, why use a compiler? It's because the source code that you type in, if you open up a text file right now, and you typed in pragma solidity with the little indentation and the version that you're looking at, it's not gonna mean anything to a machine. Like, in order to turn this into a program that can be run, you need to compile this code, right? I hope that all makes sense. Um, Now, to actually use the Solidity compiler to compile Solidity code, basically, there's kind of two options that you can go with. There is Sol-C. Sol-C is the actual Solidity compiler. It's a command line tool that you can use. You can run in terminal. You can literally type in solc dash dash help, and it will pull up all of the pretty much everything you can do with it. It's like the starting point, right? Solc.js is kind of like a converted compiler. It's basically Solc.js is a node library. Uses JavaScript, Solc.js. You can use npm install solc. That is the code to be used. Basically, to kind of understand the difference, solc.js, like I said, that is the node library, the solc.js node library, and solc.js without the dot, that's the command line tool that you get once you've installed the solc.js node library. Now, the next thing we need to kind of understand when it comes to the process of compiling, this right here is basically the first line of any smart contract. Pragma, Solidity, and then this little indent symbol, and then the version. Now, this brings us on to semantic versioning, which is a kind of integral part of just the foundational understanding of coding, if that makes sense. What you're seeing here is the declaration of the language that you're using. So Pragma basically just states the language that this smart contract will be written in, and you're using Solidity, so you type out Pragma Solidity. And then this indent, this is where semantic versioning kind of comes into play. So semantic versioning, you see underneath the Pragma Solidity, you see this major minor patch. Translate that to the numbers, basically, right? So the major is the 0, right? The 8 would be the minor, and the patch sort of number is 1, 5. Now these go up or down incrementally depending on, it's basically a way to denote. The way they work, the way that these numbers, version numbers change, convey meaning about the underlying code and what has been changed from one version to the next version, right? So bug fixes, the way it works is it's effectively to denote bug fixes generally, because that is what causes new versions to actually, no, that's some bullshit. Ignore the fact that I said that. Bug fixes not affecting the API increment the patch version. Backwards compatible changes to the API or additions to the API will increment the minor version. And backwards incompatible API changes increment the major version. So you remember that three-tiered kind of process, the source, object, and executable code. So changes, it's changes that will be reflected at the executable code level, right? That are backwards incompatible, such that once you've made this change, the implementation of this change renders all previous versions defunct, right? That type of change would cause a change in the major number. So a change at that level within Solidity would cause us to go from 0.8.15, the 0 would go to a 1, right? Backwards compatible changes, whereby let's say you make a change to Solidity that you get to a version 0.9, but the change that you've made to create this 0.9 version, it does not render the previous versions, the 0.8s, the 7s, the 6s, it does not render them completely useless, right? So that's kind of like a benchmark. That's why you have the minor level. It's kind of like the iPhone, which one did the Face ID? I think the 10. The 10 got rid of the home button, right? So that would be, I suppose, a major change, because that functionality is now rendered completely. This is a terrible example, but that functionality is basically rendered defunct beyond that version, right? So that would be a major change. But the iOS versions, because you can run the same OS on an iPhone 10 right up to an iPhone 13, like those don't have a home screen either, and they use Face ID, but you can still run different versions of software on them. There's still fixes, right? Different cameras, different changes, but they don't render that model below it defunct anymore. So you could say that the iPhones 10 up to 13 kind of fall into that minor range, right? So it would be like a 0.9 or a 0.8 or a 0.7 with Solidity. Those are backwards compatible API changes, basically. And then you have the patch changes, which minor, just absolutely minor changes that do not affect the functionality of anything. Well, that's not true. They affect the functionality of things, but not insofar as the API is altered drastically in a way that you can't move backwards from. As well, if they're minor changes, they fall into the patch versions, right? And that's why you see so many of those versions. So it kind of makes sense. The way that it's structured makes sense, and that is semantic versioning explained, basically. Now, semantic versioning comes into play. I mean, down the line, you'll learn more about this kind of stuff, but in terms of to keep it focused on compiler installation, right? We talked about the Solidity compiler. We talked about the converted compiler. The way that you would install these two things is literally just go to the Solidity website. It will have the links to the binary, the actual kind of packages you need to download. If you want to do it that way, you can do it via a Docker image. You can use Remix, a development environment like Remix, which we'll talk about down the line. Or you can basically raw dog it, just like install the JavaScript libraries and use the Solidity command line. Just use solc to compile your smart contract code. Remix ID, yeah. So battle ready smart contracts from your browser. Yeah, pretty pretty neat, to be honest. This is what the interface looks like, and this has a compiler. It's kind of like you don't need to install things on your computer if you don't have a very sort of like a powerful machine. You don't really need a powerful machine, but if you don't have one of those, or you don't feel comfortable just messing around with the code on your computer, even though, you know, smart contract writing, testing, deploying is pretty safe. So from what I've seen so far, it hasn't destroyed my computer basically yet. But you know, if you want to avoid that, you can use Remix ID. It's literally a browser-based development environment, an integrated development environment, a developer environment wherein you can, there you go, look at this. Welcome to Remix 0.24.1. Your files are stored here. You can use this to do this and that and all that great stuff. Basically think of it as a place to write, test, and deploy your smart contracts in a kind of safe, purpose-built environment. So if you do it on your computer, first thing you're going to do is set up your environment, right? So you'll download Truffle, you'll install the NPM, like all the node libraries and all the dependencies that you'll need. That's step one. If you're using Remix IDE, you can basically just avoid that step, just skip that step entirely, because the developer environment has already been built for you. Okay, this brings us to the final the final way to install the compiler, the simplest way. Docker. Docker is a open source project, started in like 2013, and the whole point of Docker was to bring developers the ability to, the mission statement was build once, run anywhere, right? So think of it as it's a software platform that runs on these things called containers, which are small, portable, sort of lightweight execution environments. So you can install the Solidity compiler from a Docker. The way so it's containers and images and stuff like that. Honestly, the whole Docker system is worth its own explainer video. So if that's something that you're interested in, do let me know, and we can make it happen. But yeah, I think that brings us to the end of it. I've been Dharma. This has been lesson 2. Hopefully now you know how to install a Solidity compiler. Scan this QR code. It'll take you to our link tree. All of our socials are on there. If you, would like to join up some live sessions, join the Discord. If you want to stay up to date with what we're doing, check out the Twitter, enable notifications. If you want to read our educational content, our news articles, check out the Medium. You decide. It's up to you. I've been your host, Dharma. Thank you so much for being a part of it. This has been the Cryptoverse DAO. Adoption through education. Let's get it. Enjoy the rest of your Monday. Bye-bye.